My name is Kelsey Easley, and for my capstone project, I am doing the Understanding CFTR and Ethical Research for those with cystic fibrosis. What I'm going to be going through is what is the research. The research looks at how a protein called Cftr works in the body to control salt and water movement. The two relevant RCR topics that I chose were human subjects. This topic focuses on the ethical treatment of people who volunteer for medical research, especially those with the serious health conditions like cystic fibrosis. The second relevant RCR topic is research misconduct. In cystic fibrosis, misconduct could be very harmful because of false or misleading information, which could lead to unsafe treatment or loss of trust from patients and families. Am I actively doing this research? I am unfortunately not doing this research yet, but I hope to one day do it. My daughter was diagnosed with cystic fibrosis at birth. I want to be a part of the effort to help find a cure, as there is no cure for cystic fibrosis. The research is important to me because it helps explain how CF works in the body at the very tiniest level. It shows new ways that we might be able to fix it. And then I really admire the work that the scientists are doing in this research, and I really hope one day to be involved in it. Research, the aim, method, and the broader significance. CFTR is a protein channel that controls the salt and water balance in the body. So for those to do a little backstory on cystic fibrosis is where your body overproduces salt and it thickens your membrane linings and all of your mucus. This looks at the gene that is involved in the salt regulation in the CFTR module. So it has the malfunctioning CFTR, and that's what causes cystic fibrosis. I'm going to start calling it CF. Scientists have studied its function using electrical signals, and they recently revealed two structural shapes of CFTR. The study then looks at a single molecule tracking it using electrophysiology and simulations. It found that two parts of the CFTR must come together before the channel opens. Now, this creates the opening to allow salt to pass through easily. ATP energy powers the CFTR to open and close, allowing chloride ions, which is your salt, to pass through. Drugs like Cftr and the GLPG 1837, which are modulators, help the CFTR stay open longer after the NBDs connect. And then these findings help explain how CFTR works, and they support the development of better CF treatments. So modulators like Cftr and the GLPG 1837 actually help the ions and the channels stay open. The topic that I chose was human subject, and then this focuses on the ethical treatment of people who volunteer. It requires the informed consent. Researchers must minimize harm and maximize potential benefits. Personal information must be kept private and confidential. Participants have the right to withdraw at any time, and extra protections need to be taken with vulnerable groups like those patients with CF. CF patients are often part of these clinical trials because they are always looking to test new CFTR-targeted drugs, which are called the modulators. They are considered an incredibly vulnerable population because there is no cure for this disease. CF patients must fully understand the risks related to their health before agreeing to this, and information is, of course, needed to be kept private and confidential. Topic number 2, research misconduct, that I chose was the research. In this, research misconduct includes fabrication, falsification, and plagiarism. These actions are dishonest. Misconduct can mislead other scientists, harm public trust, and put lives at risk. How does this affect people with CF? A lot of scientists can make up the data. They can alter or omit data that shows the side effects of these modulators. They can exaggerate drug benefits in publications to gain funding or pharmaceutical support, and they can erode public and patient trust in clinical trials. I appreciate you listening to my recording, and I thank you for the opportunity. Thanks.